In this video, we're going to discuss the real-time rule execution features of Jube. Jube is free software to detect, prevent, and investigate money laundering, fraud, and compliance breaches. We're going to pick up broadly where we left off, and we're going to discuss the real-time rule functionality of Jube. Now, to start with, let's discuss the concept of a gateway rule, which is a very, very high-level filter allowing access to more computationally expensive processing in Jube. Keeping in mind that we've already created a model, and in the last video, which was explaining rapid transactional channel creation, we performed a HTTP request and response using a JSON payload. I'm going to navigate to Gateway Rules. And on the left-hand side, we're able to see all of the models that have been configured. These models, in fact, ship with the software. To create a new gateway rule, go over to the left-hand side and click on the model. In the frame, the gateway rule page will be displayed. I'm going to create a rule that filters only transaction type ID equals 1000, an arbitrary authorization identifier. So I'm going to click for it to be active, and I'm going to call it all authorizations. There are two ways to build a rule. You can either code it using an intermediary language, which simplifies the .NET language. The system can in fact support both Visual Basic and C#, with the intermediate language sitting on top of either of those. We recommend Visual Basic largely because it's more intuitive for end users. In this example, I'm going to go to Data, the data collection, and I'm going to select a field called transaction type ID, and if it is equal to 1000, then matched is true. We can see that it's not an exact replication of the VB or the C#, as we've represented collections using this dot notation. That makes it more intuitive, but when it's passed to the compiler, that is stripped out and replaced with the appropriate collection. Alternatively, we're able to use the coder to handcraft that same rule, which will be tested. In this case, it passes and compiles. And of course, that allows me to do anything that is supported in the .NET runtime. The gateway sample I'm going to set to 100%. What this means to say is that this gateway rule is to be applied across all of the traffic. Now, in an anti-money laundering use case, of course, that needs to be set to 100%. But in ultra high volume environments, a sample might be good enough. Archive sample probably needs to be set to 100% in this use case. What this refers to is, will the transaction record be stored in the databases for a long time? By putting this to 0, it can be overridden in activation. So setting this to 0, let's say, and the activation rule to 100%, it means you can store only the activations. So if you're in an ultra high throughput environment with 500 million transactions a day, for example, maybe you only want to be storing the activations and a small sample for the purposes of machine learning and analytics. Generally speaking, however, for financial transaction volumes in banks or fintechs, the volumes are not so great, so it makes sense to have both the gateway sample and the archive sample set to 100%. I'm going to set a maximum response elevation of 11. The general idea is that response codes are returned by Jube. The bigger the response code, the more severe the consequence. This is the maximum response elevation that can be emitted from the system. And I'll click Add. And it can be seen that an all auth gateway rule has now been created, and it has matched 0 times at this point because we haven't sent in any simulations. So once gateway rules have been configured to allow transactions through, abstraction rules, activation rules, and time to live counters become available. There are two ways to maintain state in the platform. One is via abstraction rules, which is reaching into online cache or an online database of transactions for a given account, IP address, device ID. The other is via time to live counters, which is similar, except it's reaching into a cache of counters that have been incremented as the result of a rule activation. Leading into rule activation, we're very careful to separate out abstraction and TTL counter recall from activation. So we'll create a velocity rule. It looks very similar to gateway rules at this stage. On the left-hand side, I have all the models. I'm going to click on detailed account financial transactions to create an abstraction rule. And I'm going to dive straight in by calling it a velocity rule. I'm going to use an entity search whereby I'm going to count up the number of transactions that have taken place on the account identifier, but it could equally be other identifiers in a 1 day period. I'm going to count it up, but I've got various other aggregate functions I could use. If we were doing a volume rule, for example, we might look at sum. The filtering criteria I'm going to apply is all foreign transactions, which means to say the billing country is not in Cyprus. So billing country is not equal to CY. And we can see that the rule has been constructed in the intermediate language, saying of the data dot billing country is not CY. Then this will be included in the count. I'm going to click response payload. All this means to say is that when I put a HTTP request in, I'll get this echoed back out. Very useful for debugging. I click add and the abstraction rule is now configured. It's a nice opportunity to discuss the difference between configuring a rule and sending that rule live. Although I've configured the rule, it needs to be synchronized for that configuration to be compiled and placed in the engine's memory. So what is happening here is that for the gateway rule and the abstraction rule, which we've newly created, they're being taken and compiled to a .NET assembly, loaded into the engine's memory, so the speed of execution will be as quick as if it were natively compiled. So I'm going to come over to the HTTP postal where I'm going to send in a transaction. Equally, this could be via AMQP. I click post. By inspecting the response body, we can see that an abstraction has been created by the name of velocity rule, showing that there has been one transaction in the last day. If I was to send in another transaction and inspect that same element, it goes up, and so on and so forth. It's important to state at this stage that just because we're counting something up doesn't mean to say that any consequence is in place. And as aforementioned, the system has been architected such that abstractions and the recall of time to live counters is kept separate from the process of activating and actually performing some consequence, such as declining the transaction. Returning to our configuration, before we move on to activation, let's just create a TTL counter definition. Looks very similar to gateway rules and abstraction rules. So I'm going to click on the detailed count financial transaction model, and I'm going to set up a TTL counter called count up. And when we count this up, I want the counter increment to live for just 1 year, after which it will drop off and decrement, grouped by the account identifier. We'll tick the response payload so that it's echoed out on the HTTP response body. I'll click add to create the TTL counter, and we'll use that later. Now, let's move on to the activation of our abstraction rule. So I'm going to create an activation rule which will activate sending out a response code in the event that the velocity rule exceeds 10 transactions. So I'm going to set it to approve by review. This implements make a checker functionality. Activate it, and I'm going to call it velocity rule threshold. And I'm going to say if the abstraction rule is greater than 10, then it is to be considered activated. We're going to do two things. We're going to set the response elevation to 10. That's a response code. Typically anything greater than 0 is considered a decline. It's the consequence of that decline that the response elevation is meant to influence. I'm also going to send a message to the activation watcher. And for good measure, let's add a little bit of color. I want all the activations to be stored long term, and I want coverage of this activation rule to be at 100%. I want to echo it out in the response payload. I also want it to be visible inside the case management system, which we'll come on to a little later on. I'm going to add that rule. I need to synchronize it. Which will compile the activation rule into a .NET assembly and make sure it's available for recall. And while that's going on, I'm going to move to the activation watcher. The activation watcher is intended to be on a call center wall. So real time, we can see what the risk landscape looks like. So I'm going to come over to my transaction simulator. Keep in mind, we have 3 transactions being counted in the velocity rule. So I need another 7 for this rule to activate. I'm going to keep posting transactions. Until such time as the velocity rule exceeds the threshold I set, and it can be observed that the velocity rule has matched. This means to say that the response code has been set to 10, where you infer anything that's not 0 to be a decline, but it will also have been ticked out to the activation watcher, a real-time streaming interface showing activations in real time. The activation watcher is not intended to be a sophisticated tool for workflow. It's just to present real-time activations up on a call center wall so that a team feels engaged. But it is one outcome from an activation rule. And in subsequent videos, we'll explore things like case management. We'll look at things like notifications. But another important means of maintaining state is TTL counters. If you cast your mind back, you recall we created a TTL counter definition. So now let's increment that TTL counter. So let's come back to the rule that we just created and expand the activation rules, selecting the activation rule. Scroll down to select the option increment TTL counter, selecting the current model and the TTL counter count up. Unlike abstraction rules, TTL counters can go across models. So it's very useful for the purposes of creating events such as address change followed by a high value transaction. But in this example, we're just interested in incrementing this counter, which will decrement automatically a year later. Date the rule and synchronize the model. Let's move back to the transaction post tool and post in a couple of transactions. Let's inspect the payload. We can see that TTL counters are now being incremented. Every time an activation rule matches, the TTL counter will be incremented. The system will automatically decrement that a year later, as that was the horizon we set in the configuration. As aforementioned, the calculation of abstraction rules and TTL counters is kept separate from activation rules, so it naturally follows that you can create an activation rule on a TTL counter value in the same manner as you might an abstraction rule. Jube is free software to detect, prevent, and investigate money laundering, fraud, and compliance breaches. It's available at Amazon Web Services Marketplace.